Hey everyone, this is Kiet from Tips, okay? So have you ever looked up at the sun and asked yourself, what exactly is the sun? I mean, everyone knows the sun is a star, but not many people knows what is the sun made of. What exactly is the history of the sun and how will the sun dies, how will it ends? We'll find out in a moment. The Sun and the rest of the solar system was formed from a giant rotating cloud of gas and dust called a solar nebula. As the nebula collapsed under its own overwhelming gravity, it spun faster and flattened into a disk. Most of the material was pulled towards the center to form our Sun, which accounts for 99.8% of the mass of the entire solar system. Like most of the matter in the universe, our Sun is neither solid, liquid or gas, but plasma. Plasma is when something is so hot that nuclei and electrons can separate and flow around freely, which creates a goo-like substance. So you can imagine our Sun as an extremely hot spherical ocean of goo. The deeper you go, the denser and weirder the goo becomes. The Sun has several layers beneath its visible surface: the core, the radiative zone, and the convective zone. These in turn are surrounded by many layers that make up the solar's atmosphere. The Sun's core is extremely dense and is the source of all its energy, which has a temperature of approximately 15 million degrees Celsius. Above the core is the region known as the radiative zone. This region starts at about 20% of the way to the solar surface and extends up to about 70% of the distance to the surface. The heat generated in the core is transported through the radiative zone very slowly. The convective zone is the outermost layer of the solar interior. It is a thick layer with approximately 200,000 kilometers deep that transport energy from the radiative zone to the surface, similar to a pot of boiling oatmeal. Here's some cool facts. The Sun is about 150 million kilometers away from Earth. This means that light from the Sun would have taken roughly 8 minutes to travel to the Earth's surface. This also means that if you look up at the Sun right now, you're actually seeing the Sun 8 minutes ago in the past. Here's some more facts. Our Sun has a radius of nearly 700,000 kilometers and a mass of about 2 times 10 to the power of 30 kilograms, which is not a very large star. Many in the universe are several times bigger, but it is still far more massive than our home planet. 330,000 Earth matches the Sun's mass, and we would need around 1.3 million Earth to fill the entire Sun's volume. The Sun fuses hydrogen into helium in its core through its gravity. The fusion of elements releases extreme amounts of energy that pushes outward to fight the enormous amount of gravity pressing it inwards to stabilize the star, keeping it in a delicate balance. When the Sun is old, which is about 5 billion years from now, the hydrogen in its core will be exhausted and the Sun will start to burn helium into heavier elements. While doing so, it will shed its outer layer, increase significantly in size, and then become a red giant with a radius of about more than 2,500 times its former size. This also means that the red giant version of the Sun would literally swallow Mercury, Venus, and probably Earth. When this process is over, more than half of the sun's mass will be lost into space as a spectacular planetary nebula, millions of kilometers across. What remains will be its former core. A white dwarf is born. A star corpse, which would be only about as big as the Earth, will steal half of the sun's mass. So that is it for the presentation. Hope everyone enjoyed, and goodbye.